Hello, scientists. Welcome to room 9, our region's largest classroom. I'm Mr. Frills. I'm the principal at KIPP St Academy here in St. Louis. Today, I'll be teaching science for second grade. However, if you are a learner and you're interested in learning more about science, this is the room to be. Come on in the room. We're going to figure out some things today, and our phenomenon today deals with erosion. It's an interesting word, funny word sometimes, erosion. I like it. But erosion itself, not so helpful and fun to see. We've been learning a lot about how wind and water can change the earth. Today, we're going to focus on wind erosion. We will observe erosion and use the engineering cycle to design and test a windbreak as a solution to prevent wind erosion. Now, if you have no idea what erosion is and wind erosion specifically, you're going to learn it today. Today is the day to learn what wind erosion is. I got you. I'm going to teach it to you all very clearly. So first, I want to tell you about the book that I have, and I'm going to read a good chunk of it because I want you to know all that you need to know about erosion. But erosion involves soil, and the name of our book is called Soil Erosion and How to Prevent It. There's a lot of good information in here, and I love to read a good book. So let's start with the beginning here. First page says, the value of soil. The value of soil. The hard, rocky surface on Earth is covered with an amazing material. It is a layer of crushed rock and organic or nature-made material called soil. Soil is only a thin layer, but it is vital for life on our planet. How soil is made. How soil is made. The surface of the earth is always changing. Mountain building and volcanoes raise and break up the land. Water, wind, and ice wear it down again. So water, wind, and ice wear down the Earth's surface. This must be what they're talking about when they say erosion. Let's keep reading. Wasting away. The Earth's surface is not flat. There are hills and slopes everywhere. Some are covered with small plants and trees, and others are bare. Gravity can pull down the material from these uplands slowly and gently, or fast and dangerously. Okay, so gravity has a part of it too. Let's see. Erosion by water. So we learned that erosion can happen with wind, water, and ice. Let's see if we can keep going here. Let's learn more about the water piece. Erosion by water. The most powerful force of erosion in nature is running water. Over time, streams can cut channels or tunnels into solid rock. They also can carry away huge amounts of soil and rock particles. Carving the Earth's surface. Not all rocks are hard. Some, such as limestone and sandstone, can be eroded by rainwater. Where soft rock lies between hard rock, the water can wear away a V-shaped groove or channel in the soft rock. Large mountains of fast-flowing water can cut similar channels in even hard rock. Large amounts of fast-flowing water can cut similar channels in even hard rock, as the Grand Canyon in North America. Check this out. The water made its way through, and it just cut through. So it used to be flat all the way across here. But now the water made its way through and it's dug its way all the way down there. Running water. So that's water erosion. Let's see about some other types of erosion. Wind and ice. Wind and ice. Dry and cold regions of Earth are also shaped by erosion. Wind moves small particles quickly from place to place. Ice grows slowly through mountains and carries huge boulders long distances. Blowing away. Dust storms are caused by winds moving over dry land with little or no plant life protecting it. Small particles are picked up and carried high in the air. Unlike streams, wind is not limited to river channels or waterway. It can carry its load over any landscape and set it down anywhere. Wow. So wind can pick up the dirt and move it other places, and that shifts the earth's surface because the soil is now moved somewhere else. But what about the people who needed the soil where it was? That doesn't work now, I guess. I wonder why soil is so important. What do people need soil for? And why is it so helpful? I think a lot of living animals depend on soil, like the ones who live in the dirt, or the animals that expect the plants, the animals who eat the animals that live in the dirt. So if we're moving the dirt, that shifts the earth around. That's not too helpful. I think we really want to make sure that erosion stops as much as possible. Let's learn about the ice. They're ice rivers. High in the mountains, snow packs down to form hard, thick ice. The weight of the ice causes it to start moving down mountains like a slow, frozen river. This is a glacier. Along the way, the heavy ice digs up and carries along huge boulders of rocks. It also pushes soil and rock out of its way, in front and to the sides, leaving mounds of dirt on the land. Wow. So as the river flows from the mountain, the icy water, it pushes the sand to the side and it pushes it forward as it moves away from the mountain. So that also shifts our soil as well. That's another type of erosion. I think we want our soil to just stay where it is, but erosion makes it move other places. Erosion may not be the most helpful. Let's read about other types of erosion. All natural erosion. Erosion is happening all the time. It is nature's way of recycling material on Earth. Natural erosion helps create valleys and floodplains. It also plays an important role in bringing nutrient to barren, lifeless areas. Wow, so natural erosion is helpful. So not all erosion is bad. Who knew that? Not all erosion is bad. Let's learn a little more. Layers of sediment. Flooding can cause a lot of damage to houses and property, but flooding can also work to improve soil. Floodplains are the flat lands on either side of a river. When the Nile River in Egypt floods, the minerals and nutrients carried in the water are deposited all along its banks. This makes the banks suitable for growing any kinds of crops. The Niger River in West Africa, the Ganges in Bangladesh, and the Missouri in the United States also have fertile floodplains. Did they say Missouri? So the Missouri River helps with the erosion? Wow, and they make fertile floodplains. Let's read about how humans have an impact on erosion. The human effect. There's a balance in nature between land that is eroded and land that is depositioned, that is made by deposition. Humans often upset the balance. Farming, logging, and construction can all make erosion worse, all choked up. The Mississippi River, that's the largest river in the United States. The Mississippi River carries a lot of sediment into the Gulf of Mexico. Irrigation adds water to the soil that may already be soaked with rainwater. This causes soil to be washed away much quicker than just by heavy rains. The Mississippi River delta becomes clogged or choked with sediment. That means too much in there that it can't pass through. Today, the delta is growing into the Gulf about 6 miles, 10 kilometers, every century. I'll read that last line again. Today, the delta is growing into the Gulf by about 6 miles every century. So every century, every 100 years, 6 miles further that is being pushed. Here's some other pieces that we need to know about. Pollution. Soil naturally has a mix of chemicals. If people add chemicals to soil, accidentally or deliberately, they can kill plants, soil, microlife, and animals that feed on them. Pollution is the adding of unwanted chemicals to land, water, or air. All pollution can poison soil. Wow. So we want to make sure that we're protecting our soil in that way as well. I wonder, how does erosion hurt the animals that live where it is? Let's see. Have you thought about that? How does erosion hurt the animals where they live? Let's see. Impact on wildlife. Erosion plays a big part in the survival of wildlife. Both plants and animals depend on healthy soil for food and living areas. Where erosion is unchecked, wildlife struggles to survive. Any changes in wildlife can affect humans too. Topsoil community. As plants and animals die and decay, nutrients are returned to the soil, so that stays in place over a long period of time because it becomes very fertile. The healthy topsoil can support a wide variety of plants and a thriving community of microlife. This attracts all kinds of larger animals to both plant and meat eaters. Interesting. So if the soil is healthy, that means more animals will come. If the soil is not healthy, then it means that animals probably won't survive and they'll be looking for more food and nutrients other places. I wonder, what effect does it have on humans? We now know about how it affects on animals, but what about humans? Let's see. Effects on humans. Humans are also affected by soil erosion and damage. Loss of soil, poor farming, and soil pollution can cause problems with our food and water supplies. Wow. 60% of our bodies is made up of clean water. Clean drinking is vital to our health. Erosion and pollution can lead to more sediment and chemicals ending up in our water supply. Clean fresh water is also important for livestock, that means animals, and crops. If cattle and crops are given polluted water, the chemicals will find their way into our food. So if our animals are eating the water pollution and our plants are getting the water pollution, it could end up in our body because we eat animals and we eat plants. We have to stop the bad erosion. Let's see if we can figure out how that works. So in a second, I'm going to show you an example of what erosion could look like. We're going to make a little pieces together and we're going to test it out with our blow dryer. We're going to simulate some wind and make a model. But then we have to work together to think and use our engineering cycle to determine, how do we solve the problem of wind erosion? We're going to try to tackle wind erosion today. If you're ready to tackle wind erosion, let me see your muscles. Put them up, put them up, put them up, put them up. Perfect. I think you're ready. Give me 1 second to set it all up. Okay, all ready. Took me a second to get it all together, but we're good to go. So first, I just want to show you what erosion could look like in our model. And then we're going to spend some time trying to figure out what the problem is and how to create a solution for it. So let's see. So I've set up on my desk here a little station for you to see. So we have some dirt here, and I just put this here just to block so that the dirt doesn't continue to fly everywhere. And then we have my handy dandy hair dryer. Really just get it all up in my hair. Just kidding, it's not on. But let's look here and we'll see all the pieces that we need. So let's imagine that this is out in the real world. This is the wind and this is the soil that we need. If I were to turn the wind on just a little bit, you'll see that it doesn't really go far much. But at times, high winds are the things that we have to worry about, and that's when the soil actually gets displaced. So I'm going to turn it up a little more to see what happens, so you can see what happens when we talk about wind erosion. Here we go. As you can see, the wind moves the dirt, and as the dirt moves, is being displaced. And what we want to see happen, we love to see all the dirt stay in the same place. The problem is that dirt doesn't stay in the same place when the wind gets really high. And it kind of blows away bit by bit. So let's see how we can solve that problem. I'm going to take 1 second to clean off my computer because there's a lot of dirt that just ended up on it. And we're going to get back to it. 1 second. Okay, so now we know what wind erosion is. But now we have to figure out how to solve this problem. But again, why is wind erosion a problem? I can't remember what we said earlier. Can somebody help me out? If you're thinking that wind erosion is a problem because it puts all of the it messes up the quality of the air that we breathe and it can put dirt into our lungs, that's a good idea, right? As the wind blows the dirt, sand, and dust around, it moves things around and we have to breathe that air. And then the other one is that we talked about earlier is around how it could move the soil that plants need. And if plants need the soil, then the plants probably won't grow and we won't have vegetables for humans or animals to eat. And if animals can't eat, then we can't eat the animals. It is a stressful process, okay? So let's figure out how we can clear up our problem. Here's the first thing we should think about. This is a cycle that engineers use to design to think through the problem that exists and then how they can create a solution for it. There's so many things in our life that engineers have created to make our life a little better because somebody identified a problem and went through the cycle to figure it out. So here are the steps to the cycle. The first is to identify the problem. I think we've identified the problem. We want to breathe good air, and we want to be able to have all the plants have all the soil that they need, so that all the animals and plants can eat. The second thing we want to do is research and brainstorm. We want to research and brainstorm ways to solve this problem. We're going to spend time doing that today. We're going to choose the best ideas, construct a prototype, test and evaluate, communicate, redesign, and then we just start the whole process all over again when we find a new problem or if this didn't work the first time. So let's think about it. Wind erosion is our issue. The wind is blowing soil away, and as wind blows it away, it makes it a little harder. Can you think of the thing that we can do that would allow us to stop the wind erosion that takes place? Think about it. What ideas do you have for solving this problem? What can you do to stop the wind erosion? What can you do to stop the wind erosion? I just came up with that in my head. I'm proud of it. So what did you come up with? I have an idea of what we can do, but I want to hear from you. I want you to think of your own ideas too, because good ideas come from multiple people and not just one person. I think we can do a windbreak. I think if we built a windbreak, it'll stop the wind from flowing and it'll block the soil. So now when the soil is blocked, the wind won't hit it and it won't take it away. But we need to come up with an idea of how to build a windbreak. And I have some materials here that I think it'd be helpful for us to have. So the first is, I got some pipe cleaners. I love these things, they're super helpful. I also have some index cards, if you ever had index cards. And I got some paper clips, a bunch of paper clips. I'm wondering if I could use these to help build our windbreak. Let me take a few seconds to try to put some things together here, because I think that I can do it. I think we can do it together. If I use my pipes here, so let's see. If we're trying to make a windbreak, we want to make sure that the wind that is strong, so that the strongest winds can keep it from being knocked down. Let's see up here. I'm going to take a few of these cards. I have my paper clips here. What if I took the cards and I clipped them together to make what looks like a little wall as they go across? Let's see. So here, another one here. I am now creating my prototype, constructing my prototype. Let's see if we can come up with some more here. I'm going to try to do 4. The only thing I'm worried about is that it won't be strong enough to hold it. Maybe I'll do 5. 5's a good number. I'm worried that it won't be strong enough to hold it. But I think my pipe cleaners can help me out with that. I feel like if I put my pipe cleaner down at the bottom and then put a and put a paper clip at the bottom, I'll be able to see how to get it strong there. Let's see if I put this here. Maybe it'll make it a little stronger and sturdier to go. Let's see. A little stronger and sturdier there. Let's see if we can put another one here. But actually, I'm gonna double up here because this is the middle. We want to make it a little stronger here. So I'll put this here. Perfect. And I go here. Perfect. Now I have what I think is a pretty strong windbreak because I can fold it around the dirt, and then when I blow the wind, it'll stay strong and sturdy on the table. Do you think it's gonna work? Well, I sure hope so. We will see. So let's see. Here's my little prototype. It's the wall that sticks together. As it sticks together, it is here and ready to hold up as we go. All right, let's put it to the test. Let's see what we come up with here. Let's take it over to our station, set up our camera so we can see if it works. And this time I'm gonna put it on this side, and I'm gonna blow from this side to see how, if the wind stops it from blowing towards you. But just to make sure that Mr. Frills' computer is safe, I'm gonna tuck this part under. Perfect. All right, let's see if it works. Oh, that one didn't work. So let's see if maybe we can do something different to make sure that it stays up as it goes so that it doesn't fall down as quickly. I wonder what can I do to make that happen. Let's see. Here we go. Oh yeah, it is blocking the air. I feel the air on my hand. It's blocking it, and as it blocks it, it doesn't move the sand. I mean, it doesn't move the soil. But if I were to remove our wind block, the soil starts to move in little bitty pieces. But if I put it back, it now holds it and it stops it from moving. I think we have a good starter design, but I also think that we can do better. So that's what all good engineers do. They make a design and they'll just stop there. Engineers continue to make and redesign and make it even better. We won't spend time doing that today, but you should always keep that in mind. But we learned so much today. We learned about wind erosion. We learned about how what wind erosion does to impact humans and animals. Now, let's see what our book told us that might be helpful for us to know about the solutions that other people have come up with for stopping erosion. Let's see. It says, stop it. Humans can slow down or stop much of soil erosion. They can do this by improving how they farm, build, and use the world around them. It's a balancing act. Flooding is nature's way of returning nutrients and materials to the land. By building flood walls and levees, people prevent this cycle from happening. People need to allow floods to happen, but in a controlled way. Also, they should not build homes or industries on floodplains. This can lead to soil loss and pollution. So that's one thing that humans can do. Make sure that they're not building on places that are likely to flood. So that's helpful. Let's see if there are any other solutions. Better farming. Farmers plow soil and turn it over, bringing buried nutrients to the surface. Plowing also helps air and water flow through the soil, breaking up the hard substance of topsoil. Farmers drill holes in the soil and sow seeds in the plants. Perfect. So if farmers just continue to turn their soil, it'll make it a little bit easier to prevent the erosion. How can you help? How you can help? We must all take part in reducing erosion. It's not just the job of farmers, builders, or scientists, although you are a scientist. By changing what food we buy, what we eat, and how we dispose of our waste, we can help protect the soil. Waste to compost. Composting is a way to turn kitchen scraps into natural fertilizer. Microlife in a compost bin breaks down vegetables, peelings, fruit skins, and eggshells into nutrients and minerals. Adding compost to your soil helps plants grow healthy root stems. It binds soils together, and so there's less wind and water erosion, and it helps the dry soils take up water. So that's one way you can help right there. You don't have to build some massive wall to be safe with erosion. You can do something as simple as making sure that the soil that you help make soil by putting your scraps of food in one specific spot, like the scraps from vegetables or your eggshells or even the pieces from fruit. So all of those things are helpful that you can do to help with erosion. And there's so much more that you can do. But you're scientists, and you don't just stop there. You continue to think more about how you can be helpful in all those ways. Here's one thing I want you to know. When you think about a problem, we have to think about how to make a solution for it. And there's ways to do that. We could either once we identify the problem, we don't just leave the problem there, we help solve it. Today we figured out that wind erosion to the land is important because it creates problems for humans, plants, and animals. We use the engineering design cycle to brainstorm, design, and simple solutions to reduce wind erosion. I hope that you enjoyed today's lessons. Thank you, scientists, for being with me, and I look forward to seeing you next time. See ya.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.